Imagine standing in the middle of a desert with the sun directly overhead. Temperatures are pushing past 120 degrees Fahrenheit. No air conditioning, no bottled water, no shade in sight. And yet, your ancestors not only survived this kind of heat, but thrived in it for hundreds of thousands of years. The story of how they did it is one of the most incredible survival tales in human history, because while every other large mammal on the African savanna was built to avoid the midday sun, early humans evolved to walk straight into it. And that single evolutionary gamble is arguably the reason our species exists today. So, let's go back roughly 2 million years to the plains of East Africa, where a group of early hominins called Homo erectus were facing a brutal problem. The climate was shifting, forests were shrinking into open grasslands, and the shade that once protected primates from the sun was disappearing fast. Most animals responded to this heat crisis by becoming nocturnal, or by staying near water holes and resting through the hottest hours. But Homo erectus took a completely different evolutionary path. Their bodies began to change in ways that would eventually make humans the best heat-dissipating mammals on the planet. One of the biggest changes was the loss of body hair. Thick fur is great for insulation in cold climates, but it's a nightmare in extreme heat because it traps warm air against the skin and blocks sweat from evaporating properly. So, over generations, natural selection favored individuals with less body hair, allowing air to flow directly against bare skin. And paired with this hair loss came a massive increase in sweat glands. Humans today have between 2 and 4 million eccrine sweat glands, covering nearly every inch of skin, which is far more than any other primate. Chimpanzees, for example, rely mostly on panting to cool down, similar to dogs. But humans developed a full-body cooling system that could dump heat through sweat far more efficiently. And this mattered because sweat evaporation is one of the most effective cooling mechanisms in the animal kingdom. A human can lose over a liter of sweat per hour during intense heat exposure, and that evaporation pulls heat directly off the skin's surface. But here's the catch. This system only works if there's enough water to replace what's lost. So ancient humans had to become masters of finding, storing, and conserving water. And this is where their intelligence started working alongside their biology. Early humans learned to read the landscape for signs of underground water. They dug shallow wells in dry riverbeds. They used ostrich eggshells and animal stomachs as makeshift canteens to carry water across long distances. And some groups, like the ancestors of the Sand People in the Kalahari Desert, developed techniques to extract moisture from roots and tubers buried deep underground when surface water was nowhere to be found. But water management was only part of the puzzle. Ancient humans also had to master timing. They figured out that the deadliest hours were between roughly 11 in the morning and 3 in the afternoon. So many hunter-gatherer groups structured their entire day around avoiding that window. They would hunt, gather, and travel during the cooler hours of early morning and late afternoon. And during the peak heat, they would retreat into shaded areas, rock shelters, or the thin shadows cast by acacia trees, resting quietly to conserve energy and water. This behavior, sometimes called a midday siesta pattern, wasn't laziness. It was a survival strategy passed down through generations, because the groups who ignored it simply didn't survive long enough to pass on their genes. And speaking of hunting, one of the most fascinating adaptations ancient humans developed was something scientists call persistence hunting. This is where early humans would chase prey animals like antelope, not through speed, because humans are nowhere near as fast as a sprinting antelope, but through sheer heat endurance. Antelope and most four-legged mammals cool down primarily through panting, and panting doesn't work well when an animal is running at full speed because it can't breathe deeply and run hard at the same time. So early human hunters would track an animal for hours under the blazing sun, keeping it moving just enough that it could never stop to properly cool down, while the humans, upright, hairless, and covered in sweat glands, could keep jogging steadily, dissipating heat the entire time. Eventually, the antelope would collapse from heat stroke, unable to regulate its own body temperature, while the human hunters, dehydrated but alive, would finish the hunt. This hunting method is direct proof that ancient humans didn't just survive extreme heat. They actually used it as a weapon, turning their unique cooling adaptations into an evolutionary advantage over faster, stronger animals. Now let's talk about body shape, because this is another brilliant adaptation that often gets overlooked. Populations that evolved in hot, arid climates, like parts of East Africa, tend to have taller, leaner body types with longer limbs. This body shape follows something biologists call Allen's rule, which states that animals in hot climates tend to have elongated limbs and slimmer builds, because this increases surface area relative to body volume. And more surface area means more room for heat to escape through the skin. Compare this to populations that evolved in cold climates, who tend to have shorter, stockier builds that conserve heat by minimizing surface area. This is a perfect example of how the human body itself became a walking heat management tool, shaped by thousands of years of natural selection responding directly to environmental pressure. And it wasn't just body shape and sweat glands, skin pigmentation played a massive role too. As early humans lost their body hair and exposed more skin to direct sunlight, they needed protection from ultraviolet radiation. So populations living near the equator developed higher levels of melanin, the pigment that gives skin its darker tone. Melanin acts like a natural sunscreen, protecting the skin from UV damage and reducing the risk of skin cancer and folate degradation, which is critical for reproduction. This is why some of the earliest human populations in Africa had darker skin. It wasn't a random trait, it was a direct biological response to living under intense equatorial sun for generation after generation. And as humans eventually migrated to different climates around the world, skin tone shifted again to match new environments, proving just how adaptable the human body truly is when survival is on the line. But biology alone doesn't explain everything. Culture and knowledge transfer were just as important as physical adaptation. Ancient humans passed down survival knowledge orally from elder to child. Knowledge about which plants held water, which animals signaled a water source nearby, how to construct shade shelters from branches and animal hides, and how to read subtle changes in wind and sky that hinted at incoming storms or dropping temperatures. This accumulated wisdom functioned almost like a survival manual stored entirely in memory and storytelling, and it allowed each generation to build on the knowledge of the last instead of starting from zero. Groups like the Bedouin in the Arabian desert, though much more recent in history, carried forward many of these same ancient principles. Traveling by night, wearing loose, flowing robes that trap a layer of cooler air against the skin, while still allowing sweat to evaporate, and relying on deep generational knowledge of oasis locations scattered across seemingly empty desert. And this brings up another point people often get wrong. Many assume that wearing less clothing is always better in extreme heat. But desert-dwelling cultures often did the opposite. Loose, breathable, light-colored clothing actually helps regulate body temperature by blocking direct solar radiation while still allowing airflow and sweat evaporation underneath. It's a clever middle ground between exposure and protection, and it shows just how sophisticated ancient human problem-solving really was. Even without modern science to explain why it worked, they simply observed what kept them alive and repeated it, generation after generation, refining the method through trial and error until it became deeply embedded cultural practice. Now, if we zoom out and look at the bigger picture, what's truly remarkable is that surviving extreme heat wasn't a single invention or a single genetic mutation. It was a combination of dozens of small adaptations working together. Hairless skin, paired with millions of sweat glands, lean, tall bodies built for heat dissipation, dark protective skin pigmentation, intelligent water storage and location techniques, strategic daily scheduling around peak heat hours, persistence hunting that turned heat tolerance into a hunting advantage, and deep cultural knowledge passed down through storytelling and observation. All of these systems, biological and behavioral, evolved together over hundreds of thousands of years, creating a species uniquely equipped to survive and even flourish in conditions that would kill most other large mammals within hours. And honestly, when you think about it, every single person alive today carries the genetic legacy of those ancient survivors. Your ability to sweat, your body's cooling mechanisms, even certain behavioral instincts around seeking shade or resting during peak heat, all trace back to ancestors who faced down some of the harshest environments on Earth and found a way through. They didn't have air conditioning, they didn't have refrigerated water bottles or moisture-wicking fabric. All they had was their biology, their intelligence, and their ability to pass knowledge forward. And somehow, that was enough. So the next time you're complaining about a hot summer day while standing in front of your fridge or your AC unit, just remember, the only reason you're alive to complain about it at all is because thousands of generations before you figured out how to survive without any of that. And honestly, that's not just a survival story. That's one of the greatest engineering achievements in the history of life on this planet, built entirely by evolution, one drop of sweat at a time.